And happy Sunday, everyone. This is PFG Live for Sunday, the 15th of October. And CJ Stevens is reporting in on YouTube saying it's 62 and cloudy in East Tennessee. Welcome aboard, CJ. Let's see. We have Unix Carbide reporting from Williamsburg, Brooklyn, New York. 59 degrees, 22% relative humidity indoors, 51% relative humidity outdoors, and 5.64% inside the filament chamber. Excellent. And we're going to be talking about that today. Welcome from Windham, New Hampshire, where it is currently 58 degrees. And the relative humidity, well, we'll talk about that later. Oh, there's your numbers. Pretty cool. Evils is here. 19 degrees science, 46% relative humidity indoors in Ghent, Belgium. Welcome, sir. Joel L. checking in at 88 degrees Fahrenheit and sunny in Chandler, Arizona. Expected to be 100 degrees for the next 7 days. When will it end? The answer is winter. It's coming. Warren Jones checks in and he says, my weather is whatever your weather is, Spence. You are correct. And that is sky broken. Oh, well, let's go right to the Manchester weather, shall we, Warren? That's like halfway between us. Manchester Airport reporting at 1753 Zulu. Winds are 310 at 12, gusting to 19 knots. Visibility is 10 miles. Scattered clouds at 4,400 feet, broken at 15,000 feet, broken at 25,000 feet. Temperature 16, dew point 03, altimeter 2940. DBX is checking in. White Plains reporting at 1656 Zulu. Winds 310 at 16, gusting 20 knots. Visibility 10 miles. Clouds scattered at 4,200. Temperature 14, dew point 06, altimeter 2950. Let's see. Test room is checking in from, Oskapel, Netherlands. 9 degrees Celsius and 79% relative humidity. Welcome, sir. And a wonderful day it is. The weather was very pleasant yesterday and today, and we'll be enjoying some more of that. Robert Simpson is checking in at 51 degrees Fahrenheit, cloudy near Detroit. We'll go with near in an astronomical sense. On the Discord, we have Warren Jones, Evils, DBX, and Unix Carbide. Welcome, Discorders. You look very discordant. Let's see. We are set up to take a video question from the Discord crowd. Or even just an audio question. So if that happens, you let me know in Discord. But this was a good week. So yesterday, let's see. I have a picture to go with the story. Yes. Here we go. So yesterday, my son Jared and his teammates started their project where they are building a trebuchet as part of their physics class. And this is a proud tradition that started, of course, with Sam. And now it continues with Jared in his physics class. Hey, Carl's checking in. Carl Tauber, all rise. Be seated. 57 degrees and sunny in Rhode Island. Now, is that the report for all of Rhode Island? Just kidding, postage stamp. So Jared and his teammates head over to Home Depot, and by head over, I mean Dad gets to drive them in the truck over to Home Depot to start buying materials for their trebuchet project. And not only did they learn about Home Depot, they learned how to evaluate the straightness of 2x4s and the flatness of plywood. So Here's a couple of slides of those guys making their way through the narrow aisles and finally to the truck, where we managed to load up $188 worth of wood. Yeah, that was just a little crazy. That was a big price for 11 2x4s and 2 sheets of plywood and a couple of hinges and stuff. That was a little scary. I did not bring PFG Stones to check the plywood for good reason. Nor did I bring a pocket flat file, sir. Okay, so this batch of 2x4s at Home Depot was surprisingly nice. Like, I was a little shocked. I was ready to see junk. And they were pretty good. We did however, reject a few of them from the lot, right? We picked them up and the guys checked them, and a few of them were a little warpy. So, but overall, I was actually pretty pleased. And the plywood also, I think we got AC. What thickness plywood did we get? I don't remember exactly. Maybe 3/8, and it was looking pretty good. So they have good looking wood. I'm not judging, but here it comes. So let's see. Oh, Wes is checking in, reporting 61 degrees and sunny in the rural Idaho. Welcome, sir. We appreciate you being here. So that was the fun project, getting those guys spun up and going. And of course, this morning's project, which I posted on Instagram, was breakfast, and I made myself a very nice portion of bacon and eggs, and enjoyed it immensely. And I needed my slideshow to remind me of that, to remind me of the magnificent protein that I enjoyed. Let's see. So I posted. K-Bonk just checked in. 62 degrees for a high, 48 degrees for a low. Presently, it's 60 degrees in the 19123. I know where you are, and it rhymes with Philadelphia. Welcome, sir. So I posted some cryptic weirdness. I know that comes as a complete and total shock to you, on Instagram, of these plastic prototypes that I made. And I immediately got a question from Deflagrate, who of course is here in another name, as to what the heck are you making there? So before I get into it, I put a picture up on the screen, and I actually have the actual live parts right here, and they have a very interesting pattern in the end. Right? They have this long slot that has a sinuous shape. And would anybody care to take a guess, before I tell you the story, as to what these things are for? Because I didn't say anything on Instagram. I thought I'd leave it as a surprise. But I'm going to use this as an example of how I like to prototype things using the 3D printers. And I think it's a useful idea, and if you don't already do it, I think it's something you should consider. I'm going to have a sip of tea. Let's see. Joel L. says bag clips. Very interesting. Evils says grabbing some sheet material. Very interesting. Joel was close. Evils is getting closer. And we'll wait for one more. I need one more guess, and then we'll go on from here. So these take about, I think printing one of these was, I want to say 25 minutes or something. It didn't take very long. But A bead former. That's a really interesting guess. Totally wrong, but interesting. Robert Simpson says a card holder for trade shows. We're getting much closer now. Very good, Robert. And Wes says parts for a time machine. Well, I heard you say that tomorrow, so you're very close. Something for way covers, says Evils. Insulators for antennae somehow. Okay, before we move on, I have to address something. The word antennae is plural for antenna, except when you say antennae, it refers to bugs. In the world of antennas, it's antennas, so no bugs. Okay, the closest answer was the Robert Simpson card holder for trade shows. So it is, in fact, a card holder. So I will show you. And the funny thing was, the photo that I posted on Instagram actually had the answer in it. A fixed antenna. No. So this is a card holder for a 3x5 file card. Okay. And the idea was I needed a card holder that was just enough to hold the 3x5 file card, but not too much to be miserable to work with. And actually, I'm using it in the other direction. I'm using it so that you would put it in from the top and it would sit there. So the reason I do this is I am a 3x5 file card guy. I like to carry around a couple of blanks. I write things on them. If you were able to look over at my board over here, my magnetic whiteboard, you'll see a bunch of 3x5 cards on magnets. So I wanted something that I could put on the edge of my little shelf here where my monitors are to hold cards. And this could be projects, ideas, tasks, or whatever. And 3x5 file cards are just fast. Okay, I don't have to open an app. I don't have to type on a little keyboard. I can whip it out, grab my Grimsmo Saga pen. Let's just dwell on that for a moment. Little ASMR. And write a card. CJ Stevens says, I have 3x5 card holders everywhere in our household. Big on note cards for notes and lists. Excellent. Widgetworks asks a very good question. Why not use restaurant ticket holders? And the answer is because I have a 3D printer. DBX says they're very satisfying to tear up and throw away when one completes the task. Yes, exactly correct. And, you know, what the mean life of a 3x5 file card around here is a couple of days, you know, maybe a week. It could be 10 minutes. But that is what we were designing. And now you have a flat over here that you could, if you wanted to glue it to something, right side up or upside down, you can glue it to something. Or, as I will describe, it could be part of a larger structure. So one of the things I was thinking of was, here's my also self-designed 3x5 file card supply. So it's a tray for 3x5 file cards with space for 2 pens. And usually there's a Sharpie and a Saga. And this is my source. And I wanted to add a card holder to the side of it. I might not do that, but that was sort of part of the motivation. CJ Stevens says he likes the upside down option. Yeah. I also like having some sort of means for holding a card on the CNC machine, like on the vertical machining center or on the grinder downstairs. So if I have notes or if I have a traveler that's going with the parts, I could take that and jam it into the holder. So downstairs on the rack, I do have a length of card holder, chart holder that has adhesive on the back, and you can order it from McMaster-Carr. But I didn't want that. I wanted to design my own. And I came up with this sinuous curve, which I have shown you previously. There we go. And I like that curve. Siri. Siri woke up. Anyway, I came up with that idea, and the card would have just enough flex to provide the friction. And the question was, how wide, I should say, do I make that slot? So the very, very first prototype I made had some 20 thousandths wide slots. Now I know that a 3x5 index card is about 7 thousandths of an inch. So I thought, gee, that should work. No, it did not work. It was very hard to put the card in. So then I said, okay, at least I've started to bound the problem. I figured out what doesn't work. That's a very important thing to do. So a 20 thousandths wide version of this sinuous slot. You know, it's a remarkable coincidence because I played bass for a sinuous slot back in the 80s. Moving on. So I then made a family of parts, and I made each slot wider. So they went from 030 to 030, 035, 040, 050, and 060. And here's, I'm going to hold up the whole gang of them right here. There they are. But you'll notice that in the top of each prototype is the measurement of the slot. This is the design slot width. So as you're messing around with these things on the bench and you're trying to figure out what works, you don't get mixed up. You don't get mixed up. Now, I'm sure this has not happened to anybody else before, but as you're messing around with a bunch of different prototypes, you can get mixed up. So by printing the numbers right onto the parts, you can't get mixed up. Now, another concept here is that originally I wanted a really, and I may still do it this way, I wanted a really long card holder. So you could have, I don't know, maybe four index cards or 4 3x5 cards stuck in it at one time and have it all be one piece. So the idea was, well, instead of doing that, which takes a long time, let's make a smaller one for one card and get that slot right. So the principle there is make a prototype that is a small portion of the final part or the final assembly and test that. The important thing there is being small, you can make it fast, especially on a 3D printer, and you can make many of them. You can make your array of sizes. In this particular case, I was changing one variable. So the one variable I was changing was that slot width, and I made an array of just that slot width. But you could have two things going on. You could have, two variables, and you can quickly print up, while you're eating dinner, you could print up the choices to test, and then you can go test it. Now, I discovered that 060 was the correct number for this nice gentle grab. It was just the right amount of grab, okay, in the 060 version. But the 050 version, it worked, but it's a little tighter. So that was interesting too. So this is the 050, and it works, but putting the card in is not soul satisfying. It's a little hard to push it in, but that also works. So I took my 5 sample prototypes with the 5 different slot sizes, and I did a focus group. I went downstairs. Oh, here we go. DBX just posted some little pictures of his. Lovely. Very nice. So we're in the same camp here. So I went downstairs and I took my index card and I took my 5 samples and I gave it to my beautiful wife, Chandra, and I said, would you please test these and tell me what you think, and then rank them in order of most preferable to least preferable. And she said the question which all focus groups are going to ask you, which is, what am I looking for? And the answer was, just put the card in, take the card out, and do that on all of them, and just tell me which one you like. And she did. And the answer was pretty predictable. She said the 060 is the one, and the 050 was okay, and the other ones were not so good. I said, thank you very much. So the principle there is you get somebody else's input that's not your biased input. You know, it's your design, so you want it to be wonderful. But if somebody else has a different opinion, and they're a user or a potential user of the thing, you want to hear that input, sooner. So the 060 is pretty nice, and can we start making a little fine tuning on that? Maybe, but I have other things I'm going to do to push that project forward. But it's quite useful for me, and I'm pretty pleased with it. Another possibility is to add things to it, add a clip, so that it can clip on the edge of my shelf here. Add a magnet so it could magnet to something. Who knows? But you make a small piece of the concept and you test it, and the 3D printers are perfect for this, because you could very quickly try something. And it doesn't have to be in its final material. It could be something that you're going to machine, and you're just trying to get a look, a feel, a functionality before you start doing the expensive stuff. So that's the answer to the little riddle as to what the heck was Spencer doing on Instagram with these parts. And I thought about it, and I said, I could have made these only, 3/4 of an inch wide just to get that feel. But then I realized, no, I think the forces associated with putting the card in and taking the card out is going to change if I only make it 3/4 of an inch. So I had to make it long enough to get that feel, and I did, and I like it. So I will be happy to post the STL of this shape, and you can do with it what you want, and that'll be in the usual place, in my links page under something logical. We'll figure it out. So that was a story on prototyping, and I do that a lot now with the 3D printers. If I have an idea, I prototype it. One of the things I did, and you might want to consider this, is I bought about 10 rolls of plain Jane PLA. It's logically the cheapest filament in all different colors. So if I have to prototype something and I want to make different parts, different colors, and just kind of put things together, and just start seeing what I think, and I'll do it in regular PLA, because it's going to have a half-life of 2 days, and then it's going to end up in the trash. I'm sorry, in plastic recycling, and therefore might as well make it out of PLA. Also, PLA in general produces very nice high fidelity prints. Not the strongest things in the world, but we're not asking them to be mechanically sound. Just have the right shape. So that was this week's epiphany as far as using 3D printing to prototype, and then that will become one of my tools here on the desk, because I got a little disorganized. I'm not going to lie, I got a little disorganized in the last few weeks because things were going fast and furious, both with work, with shop stuff, and with other things going on, and keeping organized was getting hard. So that's the other thing that motivated this. So that's the story. If you don't have a 3D printer, go get a 3D printer. I watched a YouTube video this week from what used to be called, well, it's Thomas Sandlander, and he now named his channel Made with Layers, I think is what it's called, or Built with Layers, or Made with Layers. Maybe somebody can correct me on that. And he did a second round review of Prusa's input shaping changes and and mechanical changes on the printers. And it's well worth watching if you're interested in getting a 3D printer that's not a Bamboo, which is fine, except the Bamboo just works. So during my week, and I discussed this a little bit earlier, I broke, this was actually last week, I broke my boring tool. And I was pretty bummed because I like this tool. So I got on eBay and I went searching for a replacement. And there was really no shortage of these things used on eBay. So I went and I found one that was adequate, put a couple of bids in, not bids, but offers in on a couple of other ones that were summarily rejected, sir, because you do not appreciate the value of my boring tool. Yeah. So for pretty short bucks, I ended up getting another one. But I want to talk about what failed and why, because I think it was really interesting. If you will recall, when we last met our heroes, I was boring a hole in a fixture to hold a magnet which was going to get ground. And the error in my ways, you don't know how funny that is yet, but you will, was that I moved the tool down and I hit the bottom of the bored hole and it grabbed, and on that turn, it snapped the tool. The reason it grabbed was I was moving it down, not with the automatic down feed of the Bridgeport, but I had grabbed the quill and I was gently moving it down so it would hit the stop that the automatic down feed uses to kick out. Anybody who uses a Bridgeport, I think you know what I'm talking about. It's a mechanical trip that kicks out the feed when you hit a certain spot. Well, when you're doing automatic boring, it kicks out before it mechanically hits the bottom. So when you grab the quill and you jam it down to its limit, you actually are going a little lower. And that, I think, is what caused the problem, besides the fact that it was just the operator who screwed up. So it snapped. So I collected the pieces and I brought them here. If you're watching the video, I will show you some of them. And I want to just go over a little bit about how this thing works and a little bit about why they snap. So the boring tool operates with a dovetail slide system. It's very, very similar to a milling machine table, a Bridgeport table, etc., where the part that holds the tool has, what we can call let's call it a positive dovetail, okay? And it looks like the saddle on the Bridgeport, and then the top of the tool has what we can call a negative dovetail, and it works exactly like every other machine tool that uses dovetails, okay? And it slides in, and all is well and good. However, in this tool, you want a way to lock it, because when you slide it to the position you want a way to lock it. So the way they designed this tool is the side of the dovetail, one of the sides of the dovetail, had a deep slot cut so that it would flex a little bit, and then they put screws in to tighten that flexure. Well, if you look at that slot, I'm going to try to hold it up to the camera. Okay. If you look at that slot, it is a deep, thin slot of rectangular cross section. And it leaves a little bit of material to act as a flexure. If you're watching the video, you could see that motion right there. Now, here's the problem. I think this piece of steel is hardened. This is the body of the tool. And the bottom of that slot had two stress risers. And the stress risers are, of course, the 90-degree corners of that slot. So it had a place to break. And when I did my stupid, okay, and it gave it a little bit of force that it didn't want at a time it didn't want it, that's where it snapped. And the other thing that's quite interesting is the crystalline structure of the steel at the break. And it's sort of another hint that this was not exactly designed to last forever. CJ Stevens says, doomed to fail. You are correct. It was sort of doomed to fail. So that was sort of a bummer. So in my shopping for a new tool, I found another Criterion, same size, different era. Now, interestingly, I think this is an older tool, not a newer tool. And I am putting it together here so I could show it to you. Here it is. So this tool also, same dovetail. Interestingly, this dovetail is wider than the other dovetail. Let me see if I can grab the other one. Okay. The dovetail's wider, and it does not depend on a slot cut into the steel to make a flexure. Hi, Robin. Robin's here. Robin says, amateurs. You are correct. All right. So what do? They made the, let's see if I can do this without dropping it into my tea. They made the part that has to move a separate part. Okay. And then if I rotate it, you can see the screws are on top. So now the flexure or the motion of the dovetail that's causing the locking is now a ridge rocking in a slot. Carl says you probably paid good kopecks for that piece of shit. They were both. The other one was used. This one's used. $100 class spend on both of these things. Widgetworks says you could just fix that old one, drill and tap the old parts and bolt a plate. Yeah, I know. That's why it's not in the trash. Flat Lapper says, I'll call you Gronk. No, I don't think I over Gronked it. Well, okay, I did over Gronk it. But I like the fact that this one, the new old one, is a separate piece. And there's nothing here to cause a stress riser. And if you think about where the stress goes when you flex this thing, it goes into the bowing of this little plate that's on the side. Now, if you're just listening to the podcast, I just want you to understand I fully appreciate the frustration you're feeling right now. But if you looked at the pictures on Instagram, you could probably follow along. So the reason I say that I think this is an older design is the shape of the nose. This is a kind of a cylindrical nose, and the other one had this much more, beefy looking conical nose. So I don't know. I can't tell what year it was made, but I could tell you that from the same company, we get two designs in the same size, and this design is superior. So that's what I'm going to do. I'm going to get this guy going and get back to my boring business. Interestingly, I'm just looking at this plate, and I might even be able to see a little bend in it, like somebody who has been gronking on it. But no matter. It's all good. So much was learned here. Rob Renz says, I think the conical nose went with the fine adjust. Okay, so yeah, we didn't talk about the fine adjust. The old one, I shouldn't say old one, the one I broke has the tenths adjustment on it, which I kind of like. And Rob Renz seems to think that that's when the conical nose came into being. That's possible. We'll find out. Maybe I'll even call those guys and ask them. They're in California. I think that the tenths adjuster is threaded top and bottom, so I may be able to transfer it over to the new one. We'll see what happens. But I'm sure Robin will agree that we can't leave well enough alone. So as I bring up the new one, it'll be better. We'll make it better, and then we'll put it into use. But I enjoy those. I enjoy them very much. And the adjustment screws, I think, are identical. They still are using the same adjustment screws. No significant change there. And I generally like the tool, but we'll make it better. So that was very interesting. It was really surprising. You know, if you were going to design a tool that had to have a little flexure, would you just, I mean, if it was aluminum, well, I don't know. I don't think I'd ever do it. Somebody on Instagram says you'd think they would have drilled a hole, you know, to make the bottom of that flexure round instead of that rectangular shape. Yes, I would have to agree with that. I particularly like the separate plate, but now the guys selling the tools are like, well, we have to make a separate part now. And that's a separate machining operation, separate setup, a new SKU. I could see the motivation against it, but I think it's much more reliable. Very interesting material. And WidgetWorks also suggested that I could just modify the one that broke and put a plate on the side. Also very interesting. The other thing I noticed, this was also pretty fascinating, is that because of the design, the dovetail is actually pulling two flats together. And the flats that's pulling together is this flat that you could see right here. Okay. Now the first thing you notice is on this flat, there's three little bright spots. Well, the three little bright spots is where the threaded holes caused the material to swell. It's probably when they threaded it, and it became bearing points. Also, maybe not obvious from the video, but that is a really rough surface and not exactly controlled rough surface. So, not an awesome bearing surface left on that tool. And on the other one, the one that broke is actually better. So here, this is a mixed bag here. The one that actually broke has two rails because they recessed the center and has two rails that the other part rides on. So it's a bit of a dog's breakfast as far as design methodology, design competence, and performance. So I could probably spend $1,000 and get myself a Skookum boring tool, but I don't think I'm going to do that. Or I could just get Rob Renz to make me one. What do you say, Robin? We could make a boring tool. Yeah, nobody would be able to pay for it, but we could make it. So that's the story on the boring tool. I do have another one. I have a cheap Chinese big one, which is adequate to task, but it's not great. And I kind of have a hankering for one of those wall hoppers. I'm pronouncing it wrong, but those were copied in a couple of different ways, and that looks like a fun thing to use on the manual mill. But that'll have to wait for another day. So I want to get into the topic of the software hardware major win we had this week. But if you guys have any questions, comments, or snide remarks on the current topic, let me know, because once I switch gears, there's no coming back. I'm going to have a sip of tea if that's okay. All right. Also, a report from the PFG shop. We got caught up on orders, which was delightful. And the spreadsheet is now yelling at me to make 8-inch stones. So that's the next up. And I have to say, every time I pick up one of those 8-inch stones, it's like a diving board. It's a big piece of work. So those are next up on the grinder. Okay. If you will recall, we got started on this relative humidity measurement kick. We found the $3 round hygrometers were junk. We found that even the $1. So my friend Unix Carbide sent me a couple of these little square temperature and humidity indicators. Upon ripping these apart, by the way, we noticed a very strong similarity to the round ones. So Rob Renz is actually saying that the original design was fine. It was the severe overload that caused the break. Me? The new flexure looks even more precarious, but they obviously work if Allied Engineering is still selling them. Yeah, I suppose if you don't like jam the thing into the work like a cold chisel, it would probably last a little longer. Unix Carbide is reporting in from Mobile in the Brooklyn, New York, and or for the moment you're on a bridge. It looks like, I'm not sure which bridge that is, and he's mobile and missed all the video. I'm sorry. We'll do it later. Anyway, getting back to the hygrometer story, the round ones were junk. My buddy Unix sent me this little square one, which is cute as a button, except it's basically the same topology and the same methodology. So it's nothing to write home about. Then we finally discovered this Sensorian sensor and its eval board, which became a solution for us like quickly. So that works great. A great sensor putting out great data. Then we learned that Adafruit is offering it as a device to add onto their Stemma QT bus, which is really the I2C bus coming off of their feathers. So that has been a win. And the first thing I did with it is I used the Adafruit software called Whippersnapper. And if you drop Whippersnapper onto an Adafruit feather board, of which I'm holding one up to the camera, it will immediately start publishing data to their website, to the web server that they use, that they offer, called Adafruit.io. And it starts making nice graphs and whatever you want to display that data. But it was very important to us to get long battery life. And one of the problems was in the display version, where you were reading the display continuously, those would not last terribly long on the battery. And the question was, can we get this thing into deep sleep? And I know you know the answer already, that the answer is yes. But I want to tell you the history of how we got to yes. So last year, there was a project at the high school they called The Project. And they had to build these cubes. This is one of them, of their own design. This is the one that Jared worked on, and I helped a little bit with doing the 3D printing that he specified. And buried in here, you might be able to see on the camera, is one of our favorite boards without the display. So it's an ESP32 S3 board. And they had a pressure sensor attached to it. And part of the mission was they had to report pressure. They had to read, there's a little sensor in front. They had to read a light that was blinking a message and report the message. And they were not getting great battery life. And they were using AA cells. I think 3 of them, it looks like. And they were getting insufficient battery life. So my friend Doug, who I've mentioned previously and who we've enjoyed some information from, Doug said, yeah, we try, and Doug and I are both volunteers at the high school. He says, yeah, we were trying to get that thing working, but the ESP32 has some issue where from CircuitPython, you can't get it into deep sleep to get the current down. So these things were eating batteries. So this was bugging me. So I did, in the last couple of weeks, in the wee hours, I did a deep dive. I'm looking for the picture. Let's see if I can find the picture to show you. I did a deep dive into the whole deep sleep and current consumption question. And it was absolutely true that finding the information to get this thing to do what you wanted it to do was not easy. And Adafruit provided some information. They actually had an example program. Here's how you get it into deep sleep, except their example program was written in C, not CircuitPython. So, long story short, I went into serious hacker mode. And by the way, this is the old definition of hacker, which is a hacker is one who codes quickly to solve a problem with little documentation. That is called hacking. It doesn't have a negative connotation as I'm using it. So I went into severe hacker mode and I started working on this problem and I solved it. And it took the input from like at least 5 different sources to finally get this thing to work. So there was a bit of code I had to come up with. You had to import the correct libraries from, let's see, I'm going to show you on the screen. You had to import the correct libraries from Adafruit for that board, and it was not where you think they are. I believe it was in the alarms library, because you're able to put the thing into deep sleep and set some number of seconds before it would activate a, quote, alarm, and it would wake up and then basically reboot. Well, I got it to work, and this was a surprise to Doug. It was a surprise to me, but I was starting to see, and I am presently seeing, in fact, let me show you, I will show you on the screen, our Notify server, which is reporting my various prototypes of this device. I have 4 of them running right now. And the batteries have not left the greater than 90% point on any of them. And they've been running for days. So Doug says to me, do you want me to bring over my device, which I use for measuring the current consumption of these little things? This was the device he was using to help the high schoolers on their project. I said, sure. So he comes over with this thing that's made by Nordic Semiconductor. Nordic Semiconductor is famous for making chip radios that go on all sorts of wireless devices. I'm very familiar with those. And we hooked up this thing, and he also was very interested to see the current that I was claiming, or the lack of current consumption that I was claiming. So we get this thing hooked up on my desk, and we started taking measurements of this thing, and lo and behold, it was amazing. So once the initial startup finishes after the boot sequence, so let's think about this. So in the boot sequence, this thing has to wake up. It has a bootloader. It's gonna load up code from your program. It's going to start running your program. All of this is memory intense, so it's using a lot of current. It's going to wake up the Wi-Fi. It's going to start looking for the Wi-Fi network, transmitting and receiving on the Wi-Fi network. It's going to fire up the sensor. It's going to actually fire up the screen briefly before we get a chance in our program to say, no, don't turn the screen on. So there's a whole bunch of stuff going on with current peaks of 500 milliamps. This was very interesting to see. But it all finishes up in pretty short order. It's taken its measurements. It's posted it to the net. Right now, we're posting two different ways. We're posting to the Notify server, which gives you the nice brief notifications that I was showing you. This was taught to me by DBX, Dan. But it also is going to Adafruit's Adafruit IO server. So we get this, and that's called, you need another acronym. You don't have enough acronyms today? Stand by. That's called MQTT. Don't ask me what it stands for. If anybody in the chat can tell me what MQTT stands for, I will report it. But it uses an MQTT protocol. And the correct term of art is it publishes the data to a feed, which is not to be confused with Notify, where you're posting to a topic. Unix Carbide says, I almost hit a cab when I heard I was somehow connected to those $1.50 sensors. I guess I deserve it for offloading my e-waste in New Hampshire. Yes, you do deserve it. Here's the answer. DBX reports, message queuing telemetry transport. And Evil's comments on it saying, famous for not having a queue. This is what we have to deal with. So we are transmitting to the Notify server our data. We're transmitting our data to the Adafruit IO server. And then, let's see, what else do we do? I think we finally decide to shut down and we say, okay, we're good. It does a little bit of math to figure out how many seconds to stay asleep, which in this case is 3,600 seconds because it's 60 times 60 or 3,600 seconds for an hour. And it goes to sleep. When it goes to sleep, that the number 3,600 is written into a register on the chip, and there's this little teeny process. I don't want to call it a processor, but process. I believe it's in a state machine that just counts down that register. That's all it has to do. It does everything else is shut down. Oh, there's one other special thing I didn't mention. The I2C bus, which talks to the sensor, also talks to the screen, and it powers the sensor and it powers the screen. So one of the things you have to do is shut down the I2C bus before you go to sleep, and you have to shut down their little NeoPixel LED widget because that also gets powered. You have to explicitly power that down. Then you go into deep sleep. The good news is, as you saw on the thumbnail for this video, is that once you do those things, you actually are drawing 18 microamps of current. So for the lion's share of this hour that you're staying asleep, you're drawing 18 microamps. That is what we were looking for. So we got very excited about that. And I will be posting the code of how I did that. I mean, the difference between winning and losing on this thing was like 10 lines of code. But getting the 10 lines of code correct was the hard part. So let me give you some interesting numbers. That startup sequence that has 500 milliamp peaks in it, we asked the software, the Nordic software. By the way, I ordered one of these for myself, so it's on the way. Oh, yeah. So Rob Wren says 500 femtoamp resolution on my Keithley 2450 SMU and graphing would be great for measuring that. Yes, it would. As a matter of fact, we started talking about there are special instruments to do everything we're talking about, like battery emulation and current consumption measurements, etc. And I'm sort of getting the itch for some of these, but this little widget is $90 from Nordic, and it does some pretty cool things. It's on the way. So that entire startup sequence consumed 1.8 coulombs. So for those of you playing at home who've never heard the word coulomb, a coulomb is an amp second. Okay, so if you take amps and you multiply by seconds, that's coulombs. And that is a measure of charge. So really, the batteries that you buy should not be, rated in milliampere hours. They should be rated in coulombs. So it's an amount of, you could think of it as an amount of battery. So our startup, measurement, checking into the net, all that stuff in our process uses 1.8 coulombs. And then we go into deep sleep, which for all practical purposes is like nothing. So it turned out that the 1200 milliampere hour battery, okay, which I'm showing on the screen, this little packet, little LiPo packet, that's 1200 milliampere hours. Robert Simpson says, check out EEV blog for lots of information on electronics, testing equipment, long but interesting videos. Agreed. He's excellent. EEV blog, excellent source of information. Plus, he's an Aussie. Oi, oi, oi. So, you ready for this? That battery, that 1200 milliamp battery, will power my process, making our wonderful relative. So let's see. We just got checked in here. KP4 just checked in with relative humidity 47%. That's the one we're playing with on the desk right here. 97.8 days. Let's round it down to 90 days. So the reason I was having so much trouble observing battery consumption on this device, okay, is that it was not going to die for 90 days. So our desktop measurement using the Nordic software and the Nordic hardware finally put a number to it. Wait, it gets better. If we replace the 1200 milliamp hour little rectangular pack from Adafruit with a relatively standard lithium ion cell, which I'm holding up to the camera, this is called an 18650. All right. And that means 18 millimeters in diameter, 65 millimeters long. And this is rated at 3,400 milliampere hours. This is a lithium ion battery, lithium ion phosphate, or also known as LiPo. By the way, the first Teslas ran on these batteries. So you had a car with many of these batteries that was running it. Oh, Machine NZ is secretly listening at work. I promise we will not give you up, sir. Thanks for being here. So if you replace the little LiPo 1200 milliamp hour battery from Adafruit with a 18650, which I have done, and is you may have seen pictures of it. I believe that's KP1 is running that battery. And you do the math, it will last, you ready for this? 274 days. That's once an hour reporting. Do you need to know relative humidity once an hour? Answer, no, you do not. So why don't we go to once every 3 hours, and boom, you've got, that calculates out to on the order of 1.5 years or 2 years. Let's call it a year. So basically, what we currently have in software and hardware plus one of these batteries will last 1 year. And every 3 hours, you get a report from your sensor, which is anywhere you want it to be in your, in your facility. And I think that's pretty neat. And that was kind of the goal, because we kept on talking about, well, I want to throw a sensor in this bucket or in this cooler. I want to throw a sensor in that bucket. I want to just have all these things going, and then I could watch it. So here's what it looks like. If you're watching at home, The Adafruit I/O screens are really super cool. So I am displaying 3 graphs on the screen. One is the voltage of KP4, which is the one I've been holding up. One is the relative humidity that's it's reading, and one is the temperature. Now, this is a 24-hour period, and it's interesting because you could see when the heat came up in the house around 7 a.m. You can see if you look at the relative humidity, the most recent blip in the relative humidity was me picking up KP4 from the windowsill and bringing it into the office. And then on the top, you could see the voltage. And if you just average that out visually, it's like rock steady. So what a huge win. Rob Brenz wants to sell me his Keithley for less than the current $6,870. Listen, if you want to get rid of it, let me know. Anyway, we'll talk. I know how much these things are because in the world of RF, all of these boxes cost ridiculous amounts of money, but I've never bought a new one. Let's see, is that true? Nah, technically that is true. Everything I've bought has been used and or refurbed. So this is sort of the end point I was aiming for, was to be able to have multiple sensors running for a reasonable amount of time, off-the-shelf components, and we're there. So next step is documenting all this stuff up. I'm going to get some help from Unix Carbide and DBX. Current price tag. So my little workstation here, you've seen the red thing. Let me go back to here. Everything you see right here that I'm holding, and it doesn't change much if you replace the battery with a 18650. Everything I'm holding right here is $48. So you may make the argument, well, that's kind of expensive. Well, the first thing we would do is replace the feather that has a screen for one that doesn't have a screen, and that will knock out $6, I think. But other than that, maybe we can get it down to under $40. Of course, Carl says current price tag. I get it. So that's the win. We achieved the goal, and I'm going to be next figuring out a better way to package this so that it becomes a useful little blivet. Of course, one of the things that I want to do is, if you'll recall, the desiccant holders that was designed by someone else that I gave credit for in the links page, that we could fit 3 of them in the front of the AMS. I want to put this sensor into that space, which I think is totally doable. And then you could pop them into each of your AMSs. You could throw these things in your filament buckets, whatever. And then you can have a dashboard on Adafruit and look at all your sensors. You could program it to notify you if one of the sensors goes out of spec. It could notify you if the battery gets low in any of them. This is a pretty cool system. So I will be posting this again. I'll get some help in correctly using GitHub, and I will put the stuff up. I'll put the software up on GitHub, maybe all the files, if anybody wants to reproduce the work. But again, very happy. Now, I will point out that my good friend Doug is a world-class expert in making things that do amazing work and sip very, very little current. I would say that if you, for example, look at my sticker board, if you see this sticker right there, I'm not saying that the cameras that Blink sells is anything like what we're doing, because those cameras last for a year doing video on 2 AA lithium batteries. And you can say thank you to Doug for that, by the way. And they have great antennas. Besides that. So can we do this better? Yes. Can we do it for lower current? Yes. Can we do it with off-the-shelf parts? No. So we can design something new. In fact, Doug and I are talking about it, that would use even less current, even smaller batteries, coin cells. But guys, this is like totally off the shelf, Adafruit, ready to go, and we're there. Yeah, Unix Carbide says, ooh, board fab time. Yes. Anyway, there you go. Okay, I finally I'm seeing the humor in the chat room. You guys just chat amongst yourselves. Carl said current price tag, and Rob Wren said sounded better than the voltage or resistance price. I get it. It's not like I'm not paying attention. It's just I have a lot to do. Well, that brings us to the top of the hour, and I appreciate you guys being here. And that's the report for the recent activities. If anybody has any questions, comments, or snide remarks, you can throw them in the chat right now. And in the absence of any, we're going to say, have a great week. This has been a lot of fun. More to follow on our project. There's a little bit of mechanical design coming up for a new housing that'll take our 18650 battery and our feather and our sensors. And I want to point out also that just because we're interested in relative humidity and temperature, there's a bunch more sensors that are available. There's accelerometers. There's liquid detection, like, do I have enough coolant? There is air pressure. VOC sensors, volatile, I can't remember what it stands for. VOC sensors are available for these things. So there's all sorts of things we can do with off-the-shelf parts, and it will last a very long time on a battery. I'm really surprised that this information was not easier to find on the Adafruit site. Organic compounds. There we go. Volatile organic compounds. And the reason Unix Carbide is pointing that out is that, and he says useful for printing nasty plastics, is some of the more interesting materials, when you print them, they yield some VOCs, and it's interesting to keep track of that if you're in the same room. All right, guys, you're awesome. Thanks for being here. Go make some cool stuff, and I'm going to do the same. Today's been a pretty quiet day. I might start the 8-inchers. I might take the rest of the day off. I'm not sure. Tux Garage, thanks for being here. Unix Carbide, thanks for being here. Evils, DBX, Rob Renz, Robert Simpson, Machine New Zealand, Carl Tauber, Flatlapper. Who did I miss? You guys are great for being here live. Everybody that's listening on the podcast, thanks for hanging in there and imagining in your head all the things that we were looking at on the video. After the show, I will be in the chat room on the Discord server in After Party Roundtable, and I will get the podcast out. Toot sweet. Drive safely, and we'll see you guys next Sunday. And, oh yeah, K-Bonk reports you should remember your thumbs up on the YouTube video and subscribe. Did you know that almost half of you that are enjoying the YouTube version of this are not subscribed? You should subscribe. Just, you should. We'll see you guys in the after show. In the meantime, get flat and stay flat.